All right, so hi again. So we continue with our discussion of lecture series number 7, is Central Processing Unit Instruction Cycle. Now, as you're reading up online, I just realized that I didn't mention this. As you're reading up online, you find that the idea around the CPU instruction cycle is referred to using different names, right? And in fact, I'm sure you've already noticed that I interleave or interchange the words or the phrases machine cycle, instruction cycle, right? In certain instances, people refer to this cycle itself as the fetch, decode, execute cycle, right? So it's just one and the same thing. I thought I'd put it out there. All right, so we continue our discussion of the CPU instruction cycle, machine cycle. And in the previous lecture series, we just had a recap on how your typical program is executed, right? As you double click on it or something. We also reminded ourselves of the role that the CPU plays in the execution of computer programs that are currently loaded into main memory, right? And really our focus was on the subcomponents associated with the central processing unit. So we continue our discussion by just briefly discussing the key phases associated with the CPU instruction cycle. So it turns out really that there are 4 key phases. Now, sometimes literature will cite only 3 of these, right? So the store phase is normally not cited, but it's just 4 phases, right? Typical execution of those individual instructions associated with computer programs involve 4 key phases. So fetching, decoding, execution, and storing, right, of results. So at some stage in the life cycle or in that machine cycle or instruction cycle, an instruction will need to be fetched, it will need to be decoded, it needs to be executed, and then it needs to be stored. The result of the process of the execution needs to be stored somewhere in memory, right? And if you think about it, or if you look at this diagram here, you realize that there are different components that are associated with these key phases associated with the machine cycle, the instruction cycle, right? So the fetching of instructions, right? The fetching of instructions takes place in or is done by the memory component. Or the fetching is done from main memory, right? From RAM in this case. The decoding of instructions is obviously done by the control unit, right? This has been mentioned numerous times now. Can't even remember how many times. Execution is obviously done by the arithmetic logic unit, right? Arithmetic logic unit. And then once execution is done, once the instruction is successfully executed, in the event that there are results that are generated, those results are stored into memory, right? Now, I should mention here that sometimes this word memory is loosely used to make reference to all the different types of memory components, right? So in certain instances, the temporal memory storage locations, a la the registers, would in this case be referred to as the memory component, right? Because you're storing the partial results of the execution itself. So just keep that in mind. So fundamentally, you go through a cycle, right? As the program is loaded into memory, you are executing instructions in a cycle, right? So you go in a loop really. And that loop involves fetching of instructions, individual instructions associated with the computer program, decoding of those instructions because the CPU needs to make sense out of what exactly needs to be done. And then once the decoding is done, the instruction is executed based on the result of the decoding process. So if the decoding of the instruction signals the fact that the instruction is an add instruction, then obviously the control unit will identify the operands that are associated with that add operation, and then addition will be done by the arithmetic logic unit, right? And then finally the results are stored into RAM. So very basic idea here. 4 key phases: fetching, decoding, execution, and storing, right? All right, so I thought would again just go into a short discussion, in-depth discussion again on what typically happens in these different different stages of the instruction cycle. Granted, we also have, I think, 1 or 2 examples or something with hypothetical instructions to try and understand exactly what happens behind the scenes here. Right, so, and again, I did mention here it's 3 phases, but maybe could just say 4 phases here, right? Step number 4 would be this here, right? These notes need to be updated. So the thing is, again, the store stage is normally not referenced in certain literature, right? So, but fundamentally it's supposed to be 4, not 3 really. So let's go with 4 phases here. 4 phases, right? All right. So the processing of the data, remember what the CPU is doing is nothing more than just processing input data, right? So you provide input, or an end user provides input to a computer system, and then the CPU will process that data, right? And then produce information or some sort of result, meaningful result, right? So these stages are actually numbered here. So fetching, decoding, executing, and storing, right? Step number 1, number 2, number 3, then number 4 there. Right, so typically, I guess for the purposes of those that are obsessed with in the exam, if a question was to come on what is the first stage of the machine cycle, for instance, you know that it's fetching, right? Because before anything can be done, that piece of instruction needs to be fetched from main memory, right? So that's step number 1 is fetching. Step number 2 is decoding of the fetched instruction. So the instruction in step number 1, the instruction is fetched from main memory, and then in step number 2, it needs to be decoded so that the CPU knows what needs to be done. And interestingly enough, the decoding is done by the CPU. Specifically, it's done by the control unit, which is a subcomponent of the CPU. Once the decoding is done, the instruction is executed. Now, granted, we are still abstracting the details of what the CPU does. It turns out that there are other additional steps, other things that are happening behind the scenes. And again, very, very soon we have a thorough discussion on what those gory details are all about. And by the way, very, very soon all this will be you find it extremely easy to understand. It's quite interesting how a computer works, right? But anyway, step number 3 is execution. Step number 4 is storage or storing of the result of the processing. All right, so in terms of the actual specific details associated with step number 1, which is fetching, right? Like I said, or like we said, the fetching of the instructions is done from main memory, right? So the instruction is fetched from main memory. In this case, it would be RAM or ROM or EEPROM or PROM, right? And it turns out that the whole fetching part is actually initiated by the control unit when it checks the memory address associated with the next instruction that needs to be executed. And because these instructions are executed in a loop, right, one instruction at a time, there's a mechanism in place that keeps track of which instruction needs to be executed next. And reading the previous lecture series, we introduced the special purpose register referred to as a program counter, which keeps track of the next instruction to execute. And so effectively what the control unit does is it will constantly check in each cycle, it will check the program counter so that it gets the address of the instruction that needs to be executed next, right? And so during this fetch, step number 1, obviously control unit will check the program counter, right, for the next instruction. And then the address that is in the program counter is going to be copied to the memory address register in preparation for that particular instruction to be fetched from main memory, right? So first thing is control unit to check program counter, right, to get the instruction that needs to be executed next. And then once it gets that value, the value is copied to the memory address register, all right? And by the way, once it's copied to the memory address register, obviously the program counter is incremented by 1 so that it points to the next instruction which will need to be fetched once the cycle is done for this instruction. that is supposed to be executed in this particular iteration. All right. So once the address that was in the program counter is copied to the MA or the memory address register, the instruction can then be fetched from main memory, right? And so what the control unit will do is it will play, once the address is fetched from main memory, it will place that register into another special purpose register referred as the current instruction register, CIR, right? So observe what's happening here. The address that needs to, the instruction that needs to be executed has its address being pointed to by the program counter. Control unit will get a copy of that address and then copy it to the MAR, memory address register. And then the control unit will get that instruction and put it in the current instruction register. Right? And then the instruction is then copied from the MR to the memory buffer register, right? I'm trying to see here if there's an easier way of trying to provide an example, but I think it will make sense once we go through the actual illustration. Just play along for now, right? Just I guess fake it, right? Pretend that this is all making sense, and I know it's making sense for some of you, but for most of you, maybe it might not make sense, right? What you want to do is just to follow through with a sequence of events here. What's happening, right? From the time the instruction is copied from the program counter, right, to the memory address register, and then it's fetched from main memory and then copied to the current instruction register. All right. And then the next step here is once all this is done, so the instruction is copied to the current instruction register, what will then happen is you go to step number 2 or phase number 2, which is the decoding phase. Right? So the control unit will check the current instruction register. Remember that the instruction has now been copied into the current instruction register. So the control unit will check the current instruction register, right? And then the location of the so the relevant data that's associated with what's in the instruction register will obviously be moved from memory to the register area itself, right? And then still in step number 2, right? Remember that we mentioned that there's a special purpose register called the program counter that always points to the next instruction to be executed. It only points to the next instruction that needs to be executed after the current one in step number 2, right? So the location of the instruction that needs to be executed is only identified in step number 2 once the current instruction is decoded, right? Okay. And then finally, once the decoding is done, the arithmetic logic unit will perform an arithmetic or logical operation that needs to be done. So if it's an addition, then it will add the 2 operands or something. Now, again, granted, we are abstracting a lot of things here, because it turns out that the decoding process, or rather the cycle itself, is dependent on whether that operation is an add operation, whether it's a subtraction operation, whether it's a logical operation, and you soon discover that the different hardware components on the central processing unit that are involved in the cycle itself is dependent on the type of instruction. But for now, we are abstracting all of those things, right? Leaving the detailed discussion for later during the computer architecture component of the course. For now, our interest is just to gain a firm sense of the sequence of events associated with the fetching, decoding, and execution of the instruction. So very easy, really. Step number 3 is execution, and then in step number 4, the results. The results from this execution of the instruction are then stored into registers or into memory, right? And really, we did mention that registers are nothing more than temporal storage locations, which are small little memory slots on the CPU itself. Hopefully that makes sense. Again, all we are discussing here is what happens when you fetch the instruction, when you decode that instruction, and then finally when the instruction is executed, and then subsequently results of the execution stored into main memory or into memory locations. I thought that was it's really not that hard to understand the key idea behind this fetch, decode, execute, store cycle, the machine cycle, the instruction cycle, right? The key takeaway points here really is the primary or the core hardware components that are associated with the 4 phases, right? This is what you should know. We should remember that fetching involves the main memory, right? The decoding process involves the CPU, and specifically it involves a control unit. The arithmetic logic unit is concerned with execution of the instruction once it's decoded, and then storage is associated with memory as well, because you're storing the results, right? Something else you just need to be aware of at this point in time, or at this stage of the course, is the specific things that are associated, the specific activities associated with fetching, decoding, and execution of the instructions, right? And really, you realize that in these different phases here, various hardware components on the CPU are involved. Like, for instance, fetching involves main memory. It involves the control unit, right? Because it's a control unit that actually fetches the instruction address from main memory, right? All right. I hope that was clear enough. I'm going to pause here, right? We're going to split up this lecture series, like I said, into 3. I think it'll be a lot easier to follow through with what we are discussing. So in the next part of the lecture series, we just walk through an example, right? An example of a hypothetical instruction or hypothetical instructions to consolidate or to help reinforce the ideas around the so-called instruction cycle, machine cycle. I'll see you in the next lecture series. Thanks. Brother, I'll see you in the next screencast segment.